Hey y'all, it's been a while since I've done a video. Thought I would throw a couple up real quick, just given all the changes that have happened in multi-sub optimizer over the last several months since I created the initial kind of tutorial that was out there. And he's been hard at work, making a lot of improvements. And while there haven't been any major version changes, there have been a lot of changes under the covers with MSO, as well as a lot of small usability changes that really help the new person especially, but can also even help experienced folks out there. I'm going to do a follow-up video to this one. I don't know if it'll get posted at the same time as this or if I'm going to need another day to get it done. But I'll do a follow-up kind of showing some of my results using some of the new versions, particularly around some of the default settings that I just really didn't expect to have much of an impact. So let's jump into it. Like I mentioned, a lot's changed. I'm going to walk through some of the most notable changes and improvements out there. There's always a really detailed revision history out on Andy's site. You can see the link there. I'll try to remember to drop it down in the video description. I'm going to do a quick walkthrough after I go through some of these. It's going to be a little bit like paint drying at first, just because I'm going to bullet some of the bigger things out from each release. But I will show you MSO and we'll walk through that together. So you can see what some of these things look like in practice. And then I'm going to throw together some updated recommendations based on my experience and some chatting with Andy over on AVS forum, and then throw some reminders in as well. And then, as mentioned, I'll follow up with a video kind of showing my improvements. So let's jump into it. Again, first couple of slides are going to be a little bit dry. It's just a lot of walking through these new features. So if you remember, when 1.1.0 came out, the big added feature was the configuration wizard. That was the basis for my original videos. And that config wizard made it significantly easier to get started. It would help you import your measurements. It would automatically associate those measurements with measurement groups, create your initial graphs, kind of all those different things that were very tedious prior to 1.1.0. But a lot's been done since then. So again, tons of improvements, a lot of usability. And the way that I think about these usability improvements is more like guardrails. So there are ways that, little things that Andy's put in to help kind of get people off on the right foot. There have been a lot of issues that we've seen, and we'll talk about some tips, a lot of common issues that we've seen, I should say, with folks getting started. And I'll talk about some of those in the tips and reminders. And there have actually also been some potentially significant performance improvements depending on the hardware that you're using, that you're running MSO on. And I'll talk about that in the next slide. So again, I told you it's going to be a little bit of an eye chart. It was going to be a little bit boring to walk through, but these are really the big highlights of changes that I personally found most useful. And there's a lot of these, aren't every little thing that's changed in every version. But I think they're the bigger ones. Being able to see the target line on your graph rather than having to kind of guess where it was as those lines are jumping around is great. Some minor changes to the import so that it's easier to keep track of measurements. I think that one's really important for people with bigger theaters. People that might have 4 subs and 2 rows of 4 seats. It's easy to lose track of things, so this makes it a little bit easier to import big configs. I mentioned some performance improvements. This is the first one here. Is in 1.1.3, the optimization code was rewritten to get faster results on most projects. I noticed a bit of an improvement on my side. There's another one further down in I think 1.1.5 maybe that also helped out with performance. There's a lot of changes and fixes around graphs to make the graphs easier to compare. For folks that don't have a mini DSP device and you're using something like a Trinov or anything really that can't automatically import filters, there's an abbreviated filter report that makes that stuff a lot easier to import. I was actually helping a guy out, audio guy over on AVS forum, helping him learn the ropes with MSO. The great thing about Andy, man, audio guy, threw out a request, hey, can we get a simple report for those that need to do manual filters, and sure enough, Andy threw it in within a couple of weeks. So it was great to see that. And then the last one here is again, I mentioned more graph improvements, but that 1.1.6, excuse me, is another one that really could help with performance depending on your hardware. Essentially, if you have a CPU that is capable of running multiple threads per core, Intel calls it hyperthreading. I forget what AMD calls it. You can actually run a lot more threads concurrently than you could in the past. So you could, again, hardware dependent, but you could see some other performance improvements there. And then the one that I like the most, particularly, is that the changes to the config wizard gain blocks, because I think that really addresses, probably two of the most common issues I think that we see. It really helps out with getting the target level right. And there's always been a little bit of guessing in that, and I'll talk about some tips in there to kind of help with that, help set the target level, and then the gain changes make that even easier, make it less of an issue, less of a concern. So again, overall, really good changes, and we're going to walk through those right now. So we'll jump over to MSO, and I'll try to walk you through all these things. All right, so here's MSO. The first thing we're going to do is we're going to go run the measurement import wizard. It's important to note that the new gain settings are only, you could implement them manually. It's just a matter of fiddling with the gain blocks and putting them in the right place. But if you want to get started the easy way, just do a new import. And when you get done with the import, it'll automatically put those new gain blocks in place. So that's why I'm starting with the measurement import wizard. This will also let me show some other stuff. So we're going to do a sub-only config. I'm going to add some files here. So these are some measurements from my room. As always, we'll open these up, add files. Whoops, cancel. Let's do next and not add files. We're going to run the config wizard. We've got 4 subs, 3 positions. Let's get these guys labeled here. Left front, left rear, right rear. And we'll go next, and we'll get our positions. Left, MLP, right. And now this is where the first improvement comes in on the import wizard I mentioned. Previously, when you went to go select your measurements to associate with a sub at a listening position, once I selected a measurement, it would stay in the list. It wouldn't get removed. So there's been a really minor change, seemingly minor, but you notice this left front sub is no longer in this list. So as I go through and assign these, my list is actually going to get shorter, which makes it a little bit easier to get these associated with the right positions and not accidentally associate stuff with the wrong place, the wrong sub, or the wrong spot. If you have a simple config, this probably isn't that big of a deal, but if you have a bigger configuration, a bigger room with a lot of positions or a high number of subs, that's super easy. Again, small thing, but I think it's a big usability improvement. So we'll go next. We'll go ahead and create a template. I always call my first one baseline. If you guys have watched anything, you know this. I'm going to leave this all for default. We're not going to do a huge optimization or anything like that. But if I go ahead and click finish, the first thing, we're going to walk through some of the graph properties now. So the first thing that comes up is our graph properties. I'm just out of habit. I get used to renaming that first graph to baseline. So one of the big things that was changed is improvements to the axis of the graph. So let me kind of try to, hopefully this doesn't get too far off the screen. You guys can't see what's going on. So the first thing is if we go to axis here, I tend to change these to match my measurement range. I know these are 300, so we'll apply that real quick. But one of the things that I really like is on the left side, if you've ever used MSO in the past, you'll notice that when you start optimizing, the scale on the left side changes. Like it compresses and gets bigger and compresses and kind of goes higher and lower and kind of moves all over the place, which makes it really hard to see what's happening. Hard to compare because especially as it starts to zoom in, really, really small changes look like they're really, really big. So what we can do is we can change this. We can lock it in to a specific range. So maybe I'll go up to 110 here because I've got some pretty high peaks. So we're going 60 to 110. But what I can do is I can now change the division, the scale on the left very, very easily. It's really, really common. It's not an official standard, but it's kind of a de facto standard to look at graphs with a 5 dB scale on that y-axis. And that's what it defaults to, is a 5 dB scale. But if I wanted to look at something different, if I wanted a 10 dB scale, it's going to remove those and change that, and it'll keep it at this level. If I wanted to, I actually haven't tried this. We're going to see what happens if I try to put it to a 1 dB scale. Oh, it won't like it. So you can see there's going to be some limits in there. So there's a 2 dB scale, and that won't change when we optimize. So again, you're probably used to seeing it jump around. So it's really great to have that level of control and granularity. So that's the first thing. The second thing on the graphs is the target curves. So it's now really easy to put the target curve on the graph. And we've been able to see the target curve in the past. But this makes it a little bit easier, a little bit faster, and you don't actually have to, it will actually default to using the optimization target level, the reference level, as the target curve. So you don't actually have to go in and put in a fake flat target curve. It will automatically adjust when you put this in. So when we'll show an example of that, so I'm going to add this in first. And when I hit apply, you're going to see it's going to be at 75 dB where it popped in, because if you've ever used it before, you'll know that 75 dB is the default reference level. So I'll go ahead and hit OK. Because we're going via the wizard, it went straight into the optimization options normal. So that's what you would experience as well. And again, notice that that reference level defaults to 75 dB here. One of the things to talk about a little bit is setting this reference level. How do we figure out the right level to target for our optimization? One of the things that I mentioned in a previous video was kind of look out here and figure out where the kind of the lowest dip is, and then set it there. But here in this situation, you can see, hey, I've got this crazy null in one of my seating positions. I can't put it down here at 60 dB. I'm going to give up all kinds of headroom. So one of the things that we're changing from, or not changing, but we're just trying to make more public from a recommendation perspective, is ignore the really big dips like this, because 99% of those are going to be fixed with some simple time alignment between the subs that MSO is going to handle with the delay blocks. And sometimes folks will also look at big peaks and dips out here, which are up higher in the frequency range, and we may not be optimizing that high in your room. So if I'm going to optimize let's say to 200 Hertz, I'm going to look out here and, I've got some big deviations, but there's still a lot. Like I've got one seat that's high and a couple that are low, and then one switches places with another. So, these are kinds of things that I would anticipate get resolved with alignment as well. That's been my experience in my room. So I think a good way to start is just look at that optimization range and just kind of pick a number in there that you think is going to be pretty good. Like I might do 95 dB for my optimization range. And then again, the gain block structure is going to help us a little bit with this. So you're not going to burn up PEQs trying to hit a target level, and we'll talk about that at the end as well. I'm not going to do a whole lot in this thing. I'm just going to run. Everything else here is pretty much basic. Setting your, I'm just going to use these are the values that I use in my room. So setting your frequency range. There's probably very little reason to run optimizations longer than 30 minutes now with the performance improvements. So even on my machine, I'm running Windows 11 in a virtual machine on a MacBook Pro with the M1 processor in it. And even in that config, I don't really run stuff longer than 30 minutes. I might run my final one a little bit longer than that, just because I'm limiting myself to only 4 CPUs. But typically that's not something that you have to do. So we'll jump in here and I'll run through this real quick, because again, I'm going to run a really quick optimization just so I can show you the filter report stuff. These are going to be fine. Let me throw a little bit of boost in there. It's customary. And yes, if I optimize to 95, my highest peak is right around 110. So that happens to work in my room. We're going to go to constraints as usual. You guys should know this now. Restrict your boost, restrict your overall cut. So there we go. We're good on this one. So I can run an optimization real quick. So I'm just going to start. I'm going to start this. Actually, no, let's do it. Let's show some more graph stuff, and then I'll run an optimization and show the filter report. So one of the other things that Andy has changed from a usability perspective is around trace naming in graphs. So what we can do here is I'm going to create another config, because if you've ever done this, if you've ever cloned config, one of the things you'll notice is the graph names get these crazy weird trace names inside the graph. It's really annoying. And then if you go and try to add measurements into a graph, you get these really, really crazy names. You have to go figure out which one's which, and then rename them. That's been fixed. So I'll show you this. This will be the, which calls the new features, just to make it clear, make it easy. So if I flip over to this graph, I've got a new features graph. and we'll show this one, and we can see, hey, this is the like, notice it's got the target for new features, right? Some of that stuff's been simplified, but what's really interesting is now if I go to graph properties, and if I go to data and I go to measurement groups, and now I want to select baseline, and I want to look at my baseline here at the same time so I can get an A/B comparison. Previously, if I added these things, it would say something like, config name trace bleh. Like, I can't remember what it is off the top of my head, but it'd be this really long cryptic thing, and you have to go figure out what it was to rename it. So if I add these in here now, you can't see it because we haven't optimized and they're completely overlapping. But notice I've got a left, an MLP, I've got a baseline left, a baseline MLP, a baseline right, my right, and then the target for both, right? So I've got a new features target, sorry, just the target and new features because I didn't add the baseline target in. So that's really nice. I don't have to go and click through here, look through my things and find this crazy name. So really nice, a little bit less work, a little bit easier to figure out what's what. So I'm gonna optimize this real quick, and we're gonna let it run for a minute, just so we can get some differentiation, and then get some stuff into the filter report as well. Again, I'm not gonna let it run for too long. We're not trying to show a full optimization here or anything like that. We'll just get something that looks kind of reasonable. Yeah, that's probably good enough. So we'll go ahead and give it a stop. And then anytime you stop it or one runs, you got to confirm. So here we have two different graphs. Again, you see that having that target line there is really nice. If you happen to choose like I don't want to say a random target line, but something that's not divisible by 5, it can be hard to figure out which, what's what. So having that target line in there is really great. So let's go over and take a look at the two filter reports. So new feature is the one that we just ran the optimization on, and I want to show the original filter report first. So in the original filter report, this is the output for each filter. So I know that's a little hard to see. I don't know if I can zoom in on that. Nope, can't. Whoa, I can zoom in, and that is not what I wanted to do. A little too big. I don't think I need to zoom in so you guys to see the details. But this is the left channel, and this is the very first parametric EQ. All of this information is associated with the first PEQ. So that's one PEQ. If you've got a device that requires manual entry, you're going to have to go through and make sure you get, okay, here's the center frequency, and then, okay, here's my gain, and then here's the RBJQ value, and then, oh, I don't have an amp that uses, have an amp that uses classic, so then I have to go back down here and then find my classic bandwidth, classic Q value. Kind of a pain in the butt. So if we flip over and look at the abbreviated report, same report, but now here is that same first filter. I've got center frequency, boost, and then the two Q values so that I don't have to go hunting for them for every single filter. Helps a lot, really, to avoid manual entry error. So that's the abbreviated filter report. The last thing to look at is the performance metrics. So if you remember, performance metrics are the easiest and most quantifiable way to compare two different results. Some really, again, small things that are added here, like you can sort based on these listening positions now. You've been able to use custom frequency ranges. You can also calculate different SPLs, and this is going to get into that trick that I wanted to remind everybody about around using optimized or non-optimized positions, and I'll tell you about that here in a little bit. And then one thing that's nice is you can export. I think in one of my early videos, I was writing all that stuff down by hand and then comparing them in a table. Just makes it a lot easier to export it, save it as a text file, and then reference back to it later on. So that's a quick overview of that stuff. But now let me jump into this little bonus trick. All right. So what's an optimized versus a non-optimized position? Well, in a config, let me minimize some of the, let me make these guys a little smaller. So there we go. We've got these measurement groups. And if you remember, a measurement group is nothing but a listening position. So in my room, when I took these measurements, I had 3 listening positions, left, main, and right. Some folks might have a row of 4, some folks might have multiple rows of seats. So you can get a relatively large number of listening positions in here. So what this does is this helps me answer a question around, I really only care about this row, but I want to know what happens in these other rows, right? So all you have to do is, and I'll go have a little bit more detail on this in a slide, so you don't have to play back and listen to me. You can just find the slide with the information on it. But I can just say disallow optimization. So what that's going to do is the icon turns kind of a gray color. You see that? Now, when I run an optimization, it's not actually going to optimize that position. It's going to show me what happens, but it's not going to include it from an optimization perspective. So I'll show you what that looks like. I can go in here and let me reset my parameters. I've got that left position ignored now. So let me optimize this. And you'll see that the left, which in this graph is this kind of dark black. Is that black or blue? I can't quite tell. I think it's a dark blue. But you'll notice that dark blue position is a lot further apart from the other positions. It's just because it's ignoring it. All you're seeing is the impact of the other position's optimization on that. Like here's some pretty big swings, pretty big differences, which we don't typically see. So again, can be useful for folks with multiple rows. For folks with multiple rows of seating, it's become really popular to have one row of theater seats and then maybe like a stand-up bar behind them for casual viewing. Maybe you just want to see what things are going to sound like there. Again, good option, really easy thing to see. So let's flip back over to our to the presentation slides, and we'll kind of walk through this real quick. So we kind of walk through all these new features. Again, nothing major. Oh, you know what I forgot to look at? I forgot to show you guys the gain block stuff. That's kind of one of the big things I wanted to show you. Let me jump back over here. So when we created, when the config wizard created this this new config for us, it automatically added gain blocks, right? Like it's always done. That's always added gain blocks. The big difference now is there's automatically a shared gain block that's added. So we can see this shared gain block. And that's in addition to the subwoofer gain blocks. What this gain block does is this gain block is set to have a pretty wide, allowable value. You can see it's allowed to go plus or minus 24 dB. What this does is this lets us, maybe we chose a bad target level, right? Maybe our target level is way too high or way too low. What this does is it gives us a single block to do a big adjustment on that target level. And then our PEQ filters can just concentrate on getting the response flat like they always do. Before, if you had a bad target level, you would actually burn really, really wide PEQs with MSO attempting to get things up to or down to the proper target level that you have specified. And the result was, instead of I'm just going to make something up. If you had 8 PEQs that you were using, it might burn 2 or 3 of them just trying to get the target level correct. And then you'd only have, 4 or 5 or 6, or depending on your device, left over to actually do EQ work. So you wouldn't get as good of results as you'd expect, right? Especially given the number of filters that were involved. So that's the first big change. Gives us a lot more cushion on choosing our target level. So even if you get this a little bit wrong, you're still going to get pretty good results when you go to optimize. The second thing is the gain blocks that are added to the subs now default to a plus or minus 6 dB range. Previously, they would be I think they were the defaults for like a mini DSP. Like they were I forget the range off the top of my head, but it was something like, plus or minus 16 dB. It was a wide range. The problem with the wide range is and I'll show you this in my own experimentation, is you can end up with sub gains that are really drastically different from one another. I think in the worst case in my room, I had like an 8 or 9 dB difference from sub to sub, that's huge, right? What is that, a 8x power difference between subs, which is not necessarily a good thing. It causes all kinds of weird little, the thing that annoyed me is I would have one sub that wouldn't turn on until I had the volume cranked up, and then they'd finally all turn on and I could actually listen. So simple example. But again, these gain blocks with these settings in this manner give us a little bit more guardrails, especially for newer folks. And even again, I used it and I got great results, and I'll show that in the next video. But these gain block changes really do help out quite a bit. Now let's go back over to the deck and we'll finish up. So I did just walk through the bonus trick, and this is the example that I use. It's got the actual menu path to this. Whoops, go back one. Sorry. Down here, this second bullet is the menu path to find it. So config, optimization, measurement groups, and you can just right click on it and say disallow. And this question in bold is an example of the question that you can answer with that. I really only care about this row. It's probably the most common one, but I want to see what happens in the other positions too. Just don't want to optimize for them, right? So we'll kind of wrap up with some recommendations and reminders on a few things. Again, we still see it all the time when people are asking for some help. Always use a timing reference when you take your measurements in Room EQ Wizard. For those of you using the more common or most common USB mics, that's going to be the acoustic timing reference. Once you set it once, you don't have to worry about it. It'll stick between runs and opens and closes of Room EQ Wizard. It's a hard requirement. Can't get good results without it. We mentioned this second bullet when we were talking about setting the target levels. Ignore those really big notches and suckouts, particularly the ones at the higher frequency. I mentioned it when we walked through there in MSO, but time alignment's going to fix the vast majority of these things, and we don't want to give up more headroom than we have to get a nice flat response. This one is one that I hadn't talked about yet, but it's one that's come up pretty recently, and it does somewhat relate to setting a target level. It's really important to have full bandwidth measurements. This is even for sub-only configs, and what we mean by full bandwidth measurements is from 10 to 300 hertz, with not taken on the LFE channel where the LPF is set at 120. I think Denon Marantz has a customizable low pass filter. Crank that puppy up. I think it goes up to 250 hertz. You want to get as wide a bandwidth of a measurement as you can, because again, if I've got a target level and my response is rolling off, my natural response is rolling off, and at 120 hertz it's down here instead of being up where I need it, I'm going to burn PEQ filters to try to fill that gap, and it's not going to do anything for me because anything that my room correction sees is just going to squash it down anyway. So get that nice EQ flat using full bandwidth measurements, and it'll end up in a better result. I'll try to show you some examples of that in the next video. Let me see if I have REW open. I don't. Next video, I'll try to remember to show you that. And then make sure you're not accidentally doubling up on crossovers. This is something that we've seen. I actually did it not too long ago myself. I was helping a guy here in town, and he had some equipment that I wasn't familiar with. And you had the low pass filter of the LFE at 120 hertz, which you expect, but we didn't turn the little crossover knob on his sub amplifier far enough to get to the bypass. So we actually had a double crossover, which resulted in a 24 dB low pass filter instead of a 12 dB low pass filter, and we had some problems getting the bass right and the sub integration right. So that's definitely something that you want to keep an eye on. I mentioned this when we talked about the gain blocks, but the new gain approach really does solve a couple of really common problems. It keeps you from burning PEQ filters, as I mentioned, to try to hit a higher or lower target level. It really reduces the chance of having radically different individual sub gain levels, which is pretty important. But it's also important to note that the gain filter, the gain block values of plus or minus 6 dB, that's going to be if you're using the wizard, that's what it's going to use, right? Because you can actually specify, and I'll show you over here real quick. We'll flip back over to MSO. If you go to tools, application options, gain, I can override this and say, this is my customizable gain values that I want to use. Maybe I don't have a mini DSP. I've got some other amp that goes, has +6 to -20. So you can set that in here, and that's great. If you set those and you manually add a gain block, then MSO will respect that. But anything added by the config wizard is going to have that plus or minus 6 dB value, like we see over here. It's not going to have this value, right? So just want to clarify what that means, because it's not not, we don't want to imply that you can't override things and MSO is going to become some, you know, locked in deal. That's definitely not the case. It's always going to be nice and customizable, but again, we're looking to put guardrails out for some of the newer folks. And again, me too. So, you know, wrapping up, you know, I highly recommend that we use new configs, because that'll get that new approach to gain structuring that's in version 1.1.6 and newer. I know I personally was surprised at the results that I got. I didn't expect to get, I didn't expect to see that much improvement. The next video I'll walk through comparing a couple of different versions. I'll show you what my native response with no alignment, no EQ. I'll show you a couple of different passes that I did with MSO with some different changes. And I've got one additional recommendation I think that probably made the biggest impact in my own sound that I'll walk you through, and I'll walk you through the reasoning behind that. So hope you enjoyed the update. Keep using MSO. As always, drop me questions and comments in the comment sections. I'm happy to respond. You know, I get notifications, so I try to respond to everybody as best I can. Other than that, have a great day. We'll see you on the next video.